So let's get started. So, like, based on your understanding from the internet, what do you think of Elasticsearch on the first and like, what is your understanding on Elasticsearch? What is your thing about Elasticsearch right now?
So I mean, so usually this Elasticsearch, it's like a search engine, and
Okay.
uh, and I mean, it responds very quick than the previous tools. So
Mm-hmm.
and also we use, I mean, to handle whenever we handle with the big data. So I mean, you have large data and you need to filter or you need to search for it. So we use this tool.
Okay, perfect. So let's get started. Whatever you said is perfectly correct and very valid, and that's what the industry is also expecting. To pick up any tool in the market, the industry folks requires these four important parameters: whether the system is stable, what is the support is there from the community and the documentation, and next is the hardware requirement, how we can scale in a much easier way, and how easy to work with the system. If these four parameters are very satisfied, then your system will or the software will become quite famous. That's the reason like Elasticsearch is like much famous. But I would don't say that documentation is pretty good, but it's improving over the time. From the versions from 0.x to till this point, there is a lot of improvement on the documentation. It's not like a single day like they have done the documentation, it's done and we are good to go. It's not like that. It's a continuous development. Documentation is always a continuous development, which makes the end user to understand the system in a much better way. That's one thing. So let's get started. So here I've just listed like five important points to be considered. Let's go point one by one. Yeah. Let's get started with the first point. The first point speaks about something called real-time distributed search and analytics engine. The first point seems to be very simple, but it contains like lot of information that we have to consider. Let's understand what is a real time first. Then let's try to hop into the other terms. So when I say something called real time, what would be the opposite of a real time? Can you give some examples of opposite of real time? Like you understand what is a real time, right? So we have some information. When the information is available at the very next moment itself, or at the same time, we call it as a real time. Do you agree with me? For example, if I am speaking with you, at the very next moment, you are able to hear me, right?
Yes.
That is something called real time. But if I speak with you over the recorded message, let's say you are not available on your phone, I'm leaving a recorded message to your mobile, but you are listening after a while. Now this becomes something called a non-real time. Do you agree? So we are not
Yes.
able to hear the message at the same time. That is what our traditional post office, all the letters and telegram are working. It is not the real time one. If you send a message to anyone, it will take X amount of time to get delivered, and the recipient has to read at some later point of time. This is the very much similar to the computer systems also. Whenever some data is available at any data source, whether the data is available the next moment or not, if it is available, then system becomes a real time in nature. That's it for point number one. What if you get like a recorded like a Netflix or Amazon Prime, where the movie is being recorded sometime back, but you are viewing it sometime later? That's not real time, right? It's kind of a batch processing. That's why people say something called real time and batch processing. The exact standard terminology, verbiage, what we are thinking over here is something called real time and a batch processing. Hope you are clear till this point, right?
Yes.
Perfect. Now let's come to the word called distributed search. So I have a job with me. Instead of I compute my job with myself, I am dividing my job across several other people to get the job done. That's what will happen generally in the classroom, right? If we want to get the total of all the mark sheet, if the professor or teacher issues the mark sheet to the student, if only one person is doing, he will take about X amount of time to get the job done. For example, if you are introducing like 10 students altogether to get the job done, so my all my speed to process it becomes like x minus n number of persons who does the operation. If there are five people, so the total number of anscript is 10 divided by 5. Each person get to do two things. So by less than a minute or so, we will be able to get the result. That's what will happen in generally, right? If you want to increase the speed, that becomes a direct proportion. If you want to increase the building construction speed, the general strategy which builders will follow is they increase the number of workers. So they try to parallelize the number of operation which can be done in parallel. Someone will be working on the breaking it, someone will be doing a plastering. So amount of people who does a job, they try to make it parallelize, then they get the job done. That's what is happening here. Here they were mentioning of something called real-time distributors. You have some operation to be displayed to the user in real time. For that, like lot of workers or lot of machine working behind the scene to get the result back to the user. Hope you're clear on the first stanza, first point, right?
Yes, sorry.
Okay. The second part is something called analytics engine. Becomes very critical here. Maybe we have heard the experience of something called SQL, like a different SQL databases which we know comes to our mind is like MySQL, MariaDB, Oracle, IBM, Postgres. These are the list of DBs comes to our mind. They all can store something, but you never heard some information or analytics in me. They can say it can be used to do analytics, but it's not to analytics engine altogether. The reason is the SQL systems are designed are kept in mind on only one thing, which is something called persistence. That's why you get to hear the word called persistence lot with the SQL people. Like you want to store something which doesn't get corrupted or should be atomic in nature. The acid property. You might heard the acid property, right? So
Yes.
whenever some data gets stored, it should be stored at any whatever cost is. If there's any transaction taking in a bank, whatever the network failure or whatever the failure is happening in the system, either the transaction should happen or not. You should not go to any tri-state. What I'm just meaning here, the tri-state, is you should not go and say at the middle point. It should always complete or should not complete. That's the expected behavior of the any system. So your analytics engine here they are trying to describe here is you can do like lot of analytics in the system with the help of Elasticsearch. Like you can do a discovery on the data set of the corpus because this system can speak with big data systems very efficiently, either the Spark or Cassandra, or this itself can work smoothly with any enterprise grade system. So if that is the case, then it becomes more interesting saying that you can do a lot of discovery from that, from the given system. That's why they call this analytics engine over here. The reason, one more reason is like if you compare the number of queries between the SQL and this Elasticsearch, you will be surprised to see that most of the SQL query equivalents are there in Elasticsearch, but there's much more or lot of more functionalities are available than the SQL background. That's the whole idea here. Hope you are clear, right?
Yes, sorry.
Perfect. Now going to the second point is built on Apache Lucene. So coming point of Apache Lucene is Apache Lucene is a Java library. Have you heard about Apache Lucene before, Vinod?
Yes, I mean, I heard about that Apache library. Yes, yes. Not exactly
Yeah.
Lucene, but I know about Apache.
Yeah, Apache is a licensing consortium. Like you might have the Apache Hadoop or Apache Cassandra, all this comes under Apache Foundation. So Apache is a foundation wherein which they have like multiple projects below that, which is the Hadoop, Spark, Cassandra, all it comes under the this consortium. So there's something called licensing also. So let's come to that point. Like Apache Lucene is a Java library which is a search engine library altogether. Just understand the word called search engine library. So whenever I just mention the word called library, Java library, only the Java developer can use it. Do you agree with me? Can a Python developer or C Sharp developer can start using the Java library? Is it even possible?
No.
Okay, that becomes a very that's a first bottleneck of any. If you have some library which is written in some language, that becomes a problem because as a non-programming background people or is it a non technology stack cannot even access the library, even though you can claim the library is super efficient. But if you're not able to interface with the system, that becomes a bottleneck. So what the Elasticsearch people did is they wrote a wrapper on top of Apache Lucene, and added like lot of functionalities inside the system. After adding the functionality, they gave the interface or the endpoint to the user as a REST interface. So the beauty of the REST interface is it can interact with any programming language in the world. So if you take from C, C++, Java, Scala, Ruby, Python and Perl, PHP, all language can understand REST API protocol, because REST API protocol indirectly translates something called HTTP protocol. So all the language will ask the facility to interact with this standard definition of standard protocol that makes system more robust. So any no, programmers or anyone just want to use system, they try to create the REST API interface from the system and connect with Elasticsearch and get the job done. Hope you are clear till this point, right?
Yes, Hari.
Yeah. One more interesting question to ponder upon is something called what is the difference between the library and a framework? This might be a tricky question. Can you make some educated case like what could be the difference between a library and a framework? Can you give some examples of a library, some examples of framework? What comes to your mind?
So I mean, framework means, I mean, it includes everything. So includes library and whatever the necessary files required to execute a program. So that
Mm-hmm.
framework contains everything. So library will be like specific. So
Okay.
there could be, I mean, like Apache POI libraries, and there could be some other libraries.
Yeah, true. Can you give example for Apache Pro library? Can you give example for framework? What comes to your mind? Any Java framework?
I mean, there are like a Spring, Hibernate.
Yeah, perfect. Okay, now let's try to make it. In a framework, you can start using the library. That's what, well, if you want, if you are using Stack or Hibernate, you can start any point of time. If you want to use some library, it's always obvious that you can just import into the system and start using it. That's the way it works. Now let's try to understand the fundamental difference between the library and a framework. As you said that framework consists of a lot of things behind it, contains all the necessary information. That is perfectly fine. Let's go one level deeper into it. If you start using any framework, if you want to create some class or if you want to do some processing in the given framework, let's say if you want to access a database using the Hibernate, they have specified the standard or the way of interpretation system. We can't do modify, right? They have defined the standard based on the Hibernate people. They have defined standard. Only by that standard you can interface with the system. Do you agree with me?
Yes,
But in case of library, there is no hardened restriction. You can use a library as you want. If you want to use it, initialize it, or if you want to use it anywhere in the system, there is no hardened restriction saying that this is the way by which can use library. That's the first fundamental difference. Framework will try to emphasize or give you a condition or a protocol. This is the protocol you should follow to get the job done. Unlike if you compare with the a library where you can't do much, like library can you are free to use by the your own style. And one more thing with the framework is framework will consist of all the security part, authentication and all the stuff which will support the ecosystem. But a library will serve only one purpose. That's the whole idea. So few examples of a library, what is there in the market are the following. Elasticsearch is a framework or a system altogether, but there's something called AngularJS, React.js. All these are the frameworks on the JavaScript. But in the same JavaScript, you may have heard something called jQuery and few other like Bootstrap, and all these are called as a library. Now, do you able to distinguish between the library and a framework in a much better way, right?
yes, Hari.
Perfect. Now let's go to the third point, which we saw something called it all provides a RESTful API access to the system. That's where that point is taken care. And regarding the scalability part comes in two flavor. One is the horizontal scalability, and next is something called vertical scalability. Horizontal scalability is just you try to have like multiple machines in your cluster, which helps you to do the job. But in case of vertical scalability, you have a hardware or you have a laptop. If you want to increase the speed of the machine, you buy extra RAM stick, or if you try to upgrade the processor, you can do the upgradation. But there's a catch. You can't keep on upgrading for a given hardware. There's always a limitation. Let's say if you are increasing like 64 GB to your like a laptop, maybe after that point you can't even really think about increasing your memory to your machine. Do you agree with me, right? That is one of the important problem with the vertical scalability. You can't grow as you think. But in case of horizontal deployment, as and when if you want to increase the load of the system, or if you want to cater the larger amount of people, it's very easy that you just deploy the lot of small machine in the cloud and they get the job done. Hope you are clear now, right? What is the difference between horizontal and vertical scalability? Now the fourth point is it's an open source platform. Like you get to access the source code, you can try to modify the source code, and you can also ship the same. That's the whole point. You don't have to pay any price for it. That's another advantage of the open source software. And next is something called schema free. So people coming from the you are aware of the SQL concepts, right?
Yes.
Okay. People are using this SQL system, like if they want to insert any data into the system, first they what they do is they try to create a database. After creating the database, they try to create a table with a table definition. Create table name student with the name, age, and address. All the individual column will have the respective data types, whether it's the varchar or age or integer, will have the respective field information. From that, what happens is if you are inserting it, all the data will be conforming to that standard. But in case of Elasticsearch, you don't have to specify the key schema in upfront. Whenever you index or insert some data into Elasticsearch, system automatically infers like what is the data type for the given field. Hope you are clear right till this point.
Yes.
System can automatically infer the type of the data what you are inserting. This feature is something called auto inference in Python. If you take a programming language like Python, you don't have to specify what is the data type. Let's say if you just say a equal to 5, then system automatically identifies that this belongs to a type of integer. If you say name equal to hello world, now it can type find it to a string. But in case of Java, it's always mandates that you have to give a data type before you declare a variable. Let's say string name equal to hello world. Only if you give by a data type in upfront before the variable name, it can accept. That's the two important thing. Likewise, system automatically infers the type from the system from the data whatever you insert. Hope you are clear, right?
Yeah, it's clear.
Okay. Now it all comes under the family of document database. Like it comes in the family of NoSQL. NoSQL has three different types. One is the key value, document based, and they have something called graph. So this comes under family of document based. Document based nothing but is a JSON document style, nothing more. Hope you are clear, right? Other
Yeah.
examples of the document-based database are the Couchbase, and you have something called CouchDB, MongoDB. All these are examples of the document-based database. Hope you are clear till this point, right?
Yes.
Let's try to understand who are the people are using Elasticsearch. These are the people are using it: LinkedIn, Facebook, Netflix, Quora, Wikipedia, Stack Exchange. These are the list of people who are using Elasticsearch as the backend engine. They are using it at one point of another. Which system or which platform you are using it more often, Vinod?
So that website you're talking about website, maybe like Facebook.
Yeah, in Facebook, I'm just saying that the Elasticsearch is being used. Can you guess or find what is a feature where they are using in Facebook? Can you think of that where they are using it in Facebook?
Yeah, maybe when you want to search for the people names, there we can use this Elasticsearch.
Yeah, perfect. Let's say if you start some typing some information, what happens is as you start typing it, you are getting suggestion right, which is nothing but autocomplete feature. If you are doing any search by entering the query string, you are being displayed with the different set of username from the system. All of these are the use cases of Elasticsearch or features of Elasticsearch. Hope you are clear right till this point.
Yes.
Perfect. Why Elasticsearch is faster? We have to always understand the question. You said in the first point, right? Why Elasticsearch is what is Elastic? You said it's much faster than the other system. What makes it faster? We have to always understand that question. If you start asking those kind of questions, you will be surprised to see that you discover like lot of information about the system. Why it is popular means there are two reasons. The algorithm is the main difference over here. You see the algorithm name here, right? The inverted index and the bk tree. So these are the algorithm which makes the Elasticsearch a much powerful component. Okay, you don't have to go in detail about this algorithm. It's just too good to know about slide. Like this algorithm makes system much faster. Clear, right? But anyways, like we will be looking of the what is inverted index in the later class, because that inverted index concept is like much required. Hope you are clear, right?
Yeah, yeah. So by using these two algorithms, this Elasticsearch built.
Is faster. Say there are like a 1620 algorithm being used in Elasticsearch. I just listed only top two, which makes the search much faster or the indexing much faster. That's the whole idea. Clear?
Yeah, clear.
Okay, let me ask you a different question. You have your data in your table in SQL table. Let's say you have a student table. When we are creating some primary key, or if you want to create some index in SQL, there's an index command in SQL, right? Hope you are aware of the index command, right? Why we are doing indexing in SQL? Generally, they create index to make your search faster. That's the whole idea. Wherever you see any where clause condition or where clause, all those fields in your SQL query would be generally indexed. If you just go and look any table in your organization, if you just want to cross verify, wherever you use a where clause, if you just cross compare with the production table, you will be surprised to see that they have the indexes being created for the given column. The reason is it will make the search faster, or else it do a linear scan. It makes our search result in a much slower fashion. That's the whole idea. Hope you are clear till this point, right?
Yeah.
Okay. And advantages of using Elasticsearch: integration into several big data platform like Spark and Hadoop. It has like a lot of supporting tool. Like if you take some other tool in the market, they have the tool as in which are the application, but here they're giving a complete ecosystem or the stack technology stack altogether. E stands for Elasticsearch, L stands for Logstash, and K stands for Kibana. So they provide a backend tool which can read the data from different source and ingest into the Elasticsearch. Elasticsearch will store it in a much efficient fashion, and it helps the Kibana to query the data from the system. So it's like end-to-end platform. It's not like any silo tool like SQL where they offer only to store this information. So they are giving utility to store the data from a different subsystem and index into Elasticsearch. They also give a UI tool through which you are able to return the content and create a beautiful dashboard. And it has the full text search query, horizontal deployment. Like you can have, if you want to increase the workload of a machine, you can choose the horizontal scalability mode, and you can just start adding the machines to the cluster and get the job done. So that's the whole idea. And it has the other benefits like replication and sharding. We will understand what is the replication sharding as we start looking on the various verbiage over here. Hope we are clear in the slide, right?
So what is the stacks means? So you're saying it's supporting a lot of stacks, right? So what does that mean? I got it. Kibana is to design. I mean, that is like a UI and it is a dashboard. So what about Lagstash?
Good question. For example, if I want to do any threat analysis, maybe let's take a simple, maybe what example I can just say. Okay, let's say in your office, there are like hundreds of computers. Okay, let's assume a hypothetical case that there are in your office there are hundreds of computers. My role as an infrastructure manager is I have to monitor all these 100 computers. Now, if I want to monitor all of these computers on my own, what is the way I will monitor a computer health generally? Generally, I will do open the computer using the remote desktop, or I will do a SSH command. If it's a Linux box, I will try to open the machine and try to understand the system performance. Yes, sir. Do you agree with me now till this point?
Yeah.
What if system itself sends the report directly to Elasticsearch? Let's say I want to capture all the logs is being generated from this all this machine. Let's say you have 100 machine. I want to capture all the system Linux logs from that machine. If I want to capture it, I don't have any option except to copy or do ICP. But Logstash is a tool which will attach to this machine, try to extract this data from the machine and will try to store it into the Elasticsearch. So it's kind of a data ingestion tool. Like you hope you have heard about ETL tool, right? Extra extraction, transformation, loading. Here the Logstash will work like an extraction tool. Hope you are clear, right?
Yeah, clear. So you mean like this tool is gonna like provide data input?
Sorry, what is going to be data input you are mentioning about?
I mean like it's gonna sending data or what exactly it is?
It sends the data from one place to another place. It's like a shipper. They call it a Logstash shipper or the shipper itself. The main duty is to transport the information from one point to a different point. That's the whole duty of Logstash.
Okay, got it.
Clear, right?
No, it's clear.
Perfect. Now let's try to understand the difference between the search engine and database. Like we might have understand you said it's a search engine. So what could be the fundamental difference between a search engine and database? The first point is the Elasticsearch is being main design kept on mind is the searching operation. They have that main design criteria to make the system faster in the senses or the search speed. But if you compare with any RDMS like MySQL or Postgres, their main philosophy is to store the data. Hope you are clear, right? Or are able to do the basic CRUD operation, create, read, update, and delete. It's not optimized for only single operation. But in case of Elasticsearch, it's designed for the search. Hope you are clear, right?
Yeah.
Okay. And the next part is search engine operates on text data and your RDMS operates on tables. What I mean by text data is, let's say if you go to Facebook and start commenting on some post, let's say you're writing a big post, all this big post comes in the free text, right? Even your blog content or resume, these are the different examples of the text data. But if you compare with the traditional table and rows and column part, you have a specific value for the each row, each column. Let's say if you have age will be like a individual entity like 21 or 24. Where you have something called name equal to Vinod or something like that. Where you have a key and a kind of you have a respective value for each column. Hope you are clear right till this point. That's the main difference on the second point. The third point is what is the algorithm which being powered for the both the system. In case of Elasticsearch, as I said, that inverted index and the BKD3 are used in the backend scene. If you want to understand how SQL database like MySQL or Postgres or MS SQL store the data, they use algorithm something called B tree. Again, this is not required, but it's good to know that these are the algorithm behind the scene to it makes it much powerful. And the fourth is a very important point. There is no transaction or asset property can be enforced on Elasticsearch. That is also one reason which makes system much faster because you are not putting some extra constraint to make system to work in the way you think. It's like a free flowing system will work as they like. But in case of a SQL system, they have property for all this authorization and they have a functionality for the asset property, which is like consistency, atomicity, consistency and isolation and duration. All these four properties will be kept on check whenever there is a data insertion. Clear?
Yes.
And the next point is whatever data which you like to store in Elasticsearch will undergo some kind of pre-processing. Only after the pre-processing, data will be ingested to the back to the system. That's the whole idea. But in case of any SQL data, data is stored as it is. There is no any transformation done here. Data is stored as it, how you insert it. That's the whole big difference. Now you are able to understand the difference between search engine and database, right?
Yeah, I got the difference. So talking about fifth one. So what do you mean by pre-processed? Pre-processed.
Yeah. So regarding the pre-processing, the data will undergo some kind of transformation before being inserted to the system. Like if you have awareness of the NLP system, there is something called, again, this topic you will understand in detail in the later class. Just to get the heads up, I'll just show you the operation, NLP operation. Let's show you the, do you see the operation over here?
Yes.
So these are the things will be happening. So the first part will have something called tokenization, lexical, morphological, stemming, and chunking. No need to think much about this, but I just want to give you the understanding that all the data, whatever is being inserted in the system, will undergo these kind of transformation behind the scene. That's the whole idea. It is not stored as we think. It is all done kind of a pre-processing. Only the pre-processed information is being indexed to the system. Hope you are clear, right?
Yeah, it's clear. And one more thing is talking about fourth point. What does that mean? Transaction on no asset property.
The transaction is like you can't guarantee that if there is a, let's say you are inserting some record like a b equal to 50 in the Elasticsearch, there is no guarantee that data would properly insert it. There is no guarantee on that area.
Okay. So, and one more thing. Why are we comparing? So you are saying this Elasticsearch is a search engine. RDBMS is used to store the data. So why are we comparing these two?
Then the reason is like why, let's say you are saying, right, why people are using Elasticsearch to the first hand. Like initially there is no, like before 8 years or 10 years, there is no Elasticsearch. Everyone were using the SQL to do the same operation. Do you agree with me, right? All of a sudden, people are now wanting to make the search result faster. Now they are making something very faster. Now we should understand that whether Elasticsearch can completely replace the system or Elasticsearch altogether a different system. Hope you understand, right? Here also you can store the data, you can retrieve the content, you can do like all sort of information. But end of a day, if you ask me a question whether I can keep Elasticsearch as a private database where I can keep on storing all this information, then you're doomed. You can't really do anything with that. If you start doing like that, there is high chance that your data will get corrupted. I'll just give an example of a company. You know about PayPal, right?
Yes.
PayPal, their primary database is still in Oracle. The pristine database or the golden data they call it, all the database is still relies on something called the Oracle system. From the Oracle system, all the downstream projects start using the big data platform like Hadoop, Cassandra, Spark, HBase, and Hive. These all done by exporting the data from the Oracle to the subsystem. You may ask you why they can't store directly in a Cassandra or HBase. The reason is SQL is designed for some kind of a higher purpose like asset compliant, and you don't lose the data. There's always a transaction guaranteed because PayPal being a transaction of a fintech company, they can't afford to lose even a single transaction or incomplete transaction. But in order to make the search result faster, do the computation faster, they can have a different subsystem because at later any point of time, if they want to reconcile it, they can use a private data store. Hope you are clear, right?
Yeah.
That's the full whole idea here altogether. You understood your basic. Now you understood.
Yes, Adi.
Perfect. Various terminologies. What we need to understand in Elasticsearch: cluster, node, mapping, field, document, and the shard. Let's understand one by one. Cluster is a group of computer which has some common logical name. So each cluster will have a different node. So now let's understand what is a node. A node is a running instance of Elasticsearch. Clear till this point? Cluster is a group of nodes where node is a individual instance of Elasticsearch. If you install Elasticsearch in your laptop and if you install Elasticsearch in your desktop, now we have two nodes in your home. One is the desktop version and one is the laptop version. Now what you can do is now you can join both your desktop and laptop and try to divide your work among these two. Like you might have also heard of something called Hadoop and Spark, something called like MapReduce and RDD. So, something like similar way you can divide your work across these machines and get the job done. Hope you're clear, right?
Yeah.
And next, something called mapping. Mapping, the other word is something called schema. Like in Elasticsearch, they have a different word called mapping schema. That's what they call as a mapping. So for each field, whatever we inserted, we can have a corresponding data type, whether it should be integer or a varchar or a string. You can define over here, and the document defines that whatever the rows we insert in SQL, let's say for we insert a row called name, age, and address, that becomes a document in Elasticsearch. They call in SQL world they call as a row, but here people call as a document altogether. Clear?
Yes.
And next is something called shard. Shard is, let me explain what is a sharding concept. In sharding concept provides partially in SQL world and very much in NoSQL world. Have you heard about partition concept in SQL before, Vinod?
No, Hari. No.
Okay, so let me just explain you by this way. For example, I'll just creating an example scenario. Let's say you have a professor comes to your class, and he is handing you the mark sheet of the students. Now you have your mark sheet of the complete classroom. So what happens is now professor says that go and collect the mark sheets or just look your mark from your Vinod, from your classmate. Now after the break, everyone comes to your place and asking what is their mark and what is their mark. So this is the initial story what I'm trying to phrase here. You're clear till this point, right?
Yes.
So what happens is all the people comes to you at maximum. How many people you can process per given second? How many people you can reply to them? How long it will take for you to say a mark of a given student? How long you'll spend?
So, can you please repeat the last statement?
So I asked a question like, you have a mark sheet with you. Let's say I'm coming to you and asking you what is my mark. How long you will take me to reply what is my mark? How long you will spend to reply the question to the mark? What is the mark I have scored? How long will it take to process the information?
So, usually it's gonna take. I mean, like it depends. So, if I have like n number of sheets with me, so probably it's gonna take time.
Yeah, correct. How can you increase the speed of your processing? The easy idea what comes to my mind is if I have a Xerox copy with me, I can divide it among my friends so that in, let's say, a population of 100, a population of 20, what I can do if I have two copies, one main copy and one secondary copy. First copy I can just say go and check with Vinod. Second set of 10 people go and check with your another friend. Will it reduce the time to get processed? Will you agree with me?
Yes, actually, it reduces half time.
Yeah. What if I'm doing one more further optimization with the original copy itself? I'm having my having like a list of a lot of pages. Let's say the mark sheet has like 5 pages. I'm creating again a scenario here. If I have 5 pages, if I give all my 5 pages to a different students altogether, now my time gets reduced further. Do you agree with me?
Yes.
This is called as a sharding in database. You have a database file. The database file is not stored as a single file. Instead, you have like multiple chunk. All this multiple chunk can be queried in parallel to get the data back from the system. That's the whole idea here. Hello, hello.
Yeah, Hari.
You can hear me, right?
Yes, yes.
You understood what a sharding is about, right?
Yeah, I got it. So, main advantage of using shard is it's gonna reduce the time.
Yeah, you see example here, right? Here they have a file. In this file, they are divided into a small chunk, 256 GB, so GB. So like instead of having like one single file, if you have like multiple file, all my CPU processor can divide my work among this file, go and access it, right? You're clear, right? How it is
Yeah.
being working. This is what happening in the all the sharding concept. They can show you the other pictures like see, you have a bigger chunk instead of having a single chunk. They divide the data into several pieces. All the pieces can be queried separately. That's the whole idea. Understood here?
Yes, sir. It's clear.
Okay, if you find something very hard, you please let me know. There's no problem on that. Okay. And
Sure.
next part is something. Yeah, this is the example of the sharding concept. You have an index. Instead of having it a single file, I have like multiple file where my data is carried over. You see here, right? Shard 1, shard 2, shard 3, shard 4, shard 5. And your right hand side, there's a very important picture on the cluster which explains about the cluster property. So this is the cluster where you have two nodes, node 1 and node 2. Can you find right? Shard 1, 2, 3. Again, you shall see shard 1, 2, 3. 1, 2, 3, 4, 5. So yeah, shard 1, 2, 3, 4. Again, in the node 2, you have shard 1, 2, 3, 4. Now, even one node goes down, will I able to access the data from the system?
Yeah. Based on
Hello?
the diagram, yes.
Yeah. So even if one node goes down for some machine failure or a hard disk failure or any system failure, at any point of time I can come back, I can able to get the content. That's the whole idea. Now you understood, right? What is the importance between the sharding concept? Sharding increases your availability as well as your throughput. That's the main advantage.
Okay. So why index is divided into multiple shards?
To have a better speed. See, I said
Okay.
example, right? Instead if I have only one file to access all the record, will it increase my speed? But if I said example of 5 pages, right? Instead of having a very single large page, if I have like multiple small file, now I can divide my mark sheet among the multiple people. I can able to get the content back from the user, right? That's the whole idea here.
Yeah. Right. So as I understand, so node, I mean group. So first, this shard divided into clusters. Cluster is divided into nodes. Is it correct?
You have to say from the other way. You have a cluster, let's say you have a cluster name called Windows cluster. In
Okay.
that cluster, you have like multiple machines or a node. You can let in that way, machines or a node. You have five desktop, you have five laptops. So you have like 10 nodes altogether. Each node will have like multiple indexes. Here we just see, you don't get to see multiple index, but let's assume there's only one index over here. So they have
Okay.
like multiple indexes. Each indexes will have like multiple shards. That's the whole idea.
Yeah.
Hope
Yeah.
you
I got it.
agree. Got it right?
Yeah.
I'll just show you one more thing also. Can you see this image over here?
Yes.
Now this guy has like what is it called? Three indexes, something called CU docs, B and will and CU MAC. And your left hand side, these are the machine names. You see here, right? They
Yeah.
have the indexes being divided, shard has been divided into multiple C, 0, 1, 0, 1, C, and this is the way by which they divide the data into multiple chunks. That's the whole idea. And this is the another example. Can you see here, right? 0, 1, 2, 3, 4. Here have like 0, 0, 0, 0. Hope you understood, right? What happens over here? If they says a chunk.
Yeah. Yeah.
Any questions till this point?
Yeah. It's clear, Hari.
Good.
Yeah.
And that's where see here the node 1, node 2, and node 3. Here they have with the primary shard and a replica shard. Primary shard is the single data has been divided into multiple files called a shard, which has the primary actual data, and the replica shard is a Xerox copy. So you understand, right? So you have like 5 pages means you will do a 5 pages Xerox copy only, right? You don't do it only for single page. Do you agree with me?
Yes.
That's the same logic. If you have like one shard, you have one replica shard. If you have five replica shard, you have five replica shard. Five primary shard, you have five replica shard. That's the whole idea. You have a cluster where you have three nodes. In this node, there are like three primary shard, which is on P0, P1, P2. These are the primary shard. And the replica shards are the R0, R1 and R2. At any point of time, if this node goes down, I can access like a P0, P1 and P2. I can do it. If this goes for a down, I can access the R1, P1, P2. Hope you understood, right, how it works.
Yeah, yeah.
And this is the terminology which we need to understand people from SQL world. This will be very easy for them to follow here. So where the cluster is called as a database, shard is called as a shard of the partition, index as a table, field as a column, and document as the row. That's the analogy over here. People coming from the SQL background. Hope you are clear, right?
Yeah, it's clear.
And this is the architecture of Elasticsearch and the Lucene. I said, right, Lucene is the fundamental building block of Elasticsearch. From Lucene, they wrote Elasticsearch. Elasticsearch allows the interfacing with the third-party application using REST API protocol. So that's the whole idea about the Elasticsearch. So where they written some additional functionality like clustering. Clustering options are not available in the Lucene. Lucene is just a library. But Elasticsearch, they wrote the clustering option and all the availability they wrote on top of Lucene. They made the system as a highly available one, and the Lucene as architecture as the below. You asked a question, right? How is the kind of any pre-processing steps is being done? If you see the raw content is being acquired, the document is being built, analyzed, and the document is being indexed in the system. That's the way the Lucene actually works. Now you understand, right, how the pre-processing step is taken care in Lucene.
If you like our videos, then subscribe to our channel and be a part of the journey with GoLogica and stay connected with the latest videos.